Today we are going to learn about the chemistry chapter, that is atomic structure. So first of all, let us learn about what is an atom. Atom is the smallest particle of an element. Here the word element is very important. Okay, my brush is already on. So the smallest particle of an element. Here we are not talking about a substance. Here we are talking about an element. So if you take an element and you try to break that element in very small pieces, the smallest piece that you can get is going to be an atom. This atom can take part in any chemical reaction and it is actually considered as the basic unit of matter because it is the smallest thing, and this only builds up the matter. Therefore, it is the smallest and the basic unit of matter. Then we saw something about elements over here. What are elements then? Elements are pure substances which are made up of one kind of atoms, and they have a same atomic number. They cannot be broken down into more substances by physical or chemical means. So if you take gold, you can't break down gold into some other substances like silver and copper. Like that you can't do. Gold is gold. Gold cannot be broken down into further more substances. So that is an element. So subatomic particles, this atom which is there, in this atom many things are there are subatomic particles in it. First is the protons, which are present inside the nucleus of an atom. These are having a positive charge and their mass is unit A. You can say it as 1 AMU, and it is located inside the nucleus of the atom. The neutrons are negatively charged while they have negligible mass, and the location is rotating in the energy levels or in these orbits. You can see this green and red, you can see that is the nucleus, and this yellow round things which are there, which I'm marking with blue, that is an orbit, and this yellow ball is an electron which is revolving around those orbits. The neutrons have a negligible charge, a neutral charge, and they again have a 1 AMU mass, and they are again located in the nucleus of the atom. You can see the green color thing here is the neutron. So nucleus is a dense part in the center of the atom where protons and neutrons are situated or found. Okay, the neutrons and protons which are there are bound together, and it is a dense part which is formed out, which is in the center of the atom, and the protons and neutrons are togetherly called as the nucleons, as they are present inside the nucleus. As the new protons which are there are having a positive charge, because and the new electrons have a negative charge, they are present in such a manner. Atomic number and mass number. What is atomic number? Atomic numbers, if you can see by the definition, elements are arranged on the basis of number of protons in their representative atoms, which is equal to the number of electrons, is the atomic number. So elements which are there, they are arranged on the basis of the number of protons in them. We all have learnt in the periodic table that the atom the in the periodic table we have learned that atomic number, in the increasing order of atomic number, the periodic table mein elements are arranged, and atomic number is nothing but the number of protons, and this number of protons is equal to the number of electrons, and this is called as the atomic number, which is also denoted by Z. Then the mass number, which is A. The mass number is the total number of protons and neutrons, that is the nucleons in the nucleus of an atom. Why is it only protons and neutrons? Why not electrons? Let's go to the previous slide. Yeah, here in the subatomic particles, you can see that the protons which are there, they are having +1 mass, while the neutrons are having +1 mass. The electrons have no mass, they have negligible mass. Therefore, the mass is always calculated on the basis of protons and neutrons. It cannot be calculated on the basis of electrons because they have negligible mass. Okay, so the whole number approximation, this mass number is a whole number approximation. Why is it a whole number approximation? Because the proton which is there and the neutron, the mass is approximately 1 am. It is not completely 1 am. It can be a slightly more than that. The electron mass is negligible, but a very slight electron mass is present. Very slight. It cannot be totally zero. Very slightly it can be present. Therefore, the actual mass can be a little, very slightly more than the mass number. Just for our convenience, we have made that into a whole number approximation. Then you have some formulae for atomic number, mass number and neutron numbers. The atomic number, as we saw, is the number of protons equal to the number of electrons. Very simple. Then you have the mass number. As we saw, the mass number, proton has 1, neutron has 1 charge, 1 mass, 1 AMU mass. So therefore, it is usually protons and neutrons. That is very clear. The neutrons. Now the atomic number which is there, the mass number which is there, the neutrons number may vary in atoms. It may not be equal to the electrons or the protons. So it varies sometimes. So the number of the mass number minus the protons number is going to be the number of neutrons. You can understand this from the mass number formula itself. Orbits, shells and energy levels. What are these orbit, shells and energy levels? The electrons revolve around the nucleus as we saw in the definite orbits. These are called as the shells. They are not present inside the nucleus. They revolve around the orbits. These are also called as the energy levels because the electrons while revolving possess some energy. Therefore, they are called as the energy levels. Okay, so we learnt about the orbits. Why is it so that these electrons actually, wait, let's go ahead, then I'll tell you. The electronic configuration. The electronic configuration, if you see, the distribution of electrons in different shells. So you have two rules for the distribution of electrons. The first rule, you have the formula which is 2n square. The shells, the naming of the shell starts from K. You have certain certain stories for which you say that the shell number starts from K and not A. Alphabetically it starts from K. So what happens is the shell number K is the first shell. The first shell, the formula is going to be 2 into 1. 1 is what? The shell number. So 2 into 1 the whole square. 1 square is equal to 1 only. So 2 into 1 is going to be 2. Maximum number of electrons in the first shell, that is K shell, is going to be 2. L shell, which is the second number of shell. So the formula for this is going to be 2 into 2 square. So 2 square is 4. 4 into 2 is going to be 8. Maximum number 8. M shell is third shell. So the formula is going to be 2 into 3 the whole square. 3 square is what? 9. 9 2s are 6. 9 2s are 18. Here I don't know why 16 is written over here. Okay, so it should be 18 over here, which is not 16. It is 18. Okay. Then N. N is the fourth shell. So the formula is going to be 2 into 4 square. 4 square 16. 16 2s are 32. In this way it is done. The second rule is that the maximum number of electrons in the valence shell, that is the last shell, cannot exceed 8 electrons. More than 8 electrons cannot be present in the valence shell. Here you can see the first 20 elements and their atomic diagrams also. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So these first 20 elements, at least these first 20 elements should be learned by heart with their atomic numbers. Just you learn the atomic number, the mass number or the atomic number, you will be able to learn all other further things. One another interesting topic of this chapter, that is isotopes. What are isotopes? Isotopes are the atoms that have same atomic number but different mass number. Atomic number is the number of protons equal to the number of electrons. Mass number is equal to the protons plus neutrons. Neutron number changes, therefore atomic number and mass number changes, and therefore these isotopes are formed. This is due to the difference in neutron number, as I told you before. They have similar chemical properties but different physical properties. Why is it that so? Because chemical properties depend on the atomic number while physical properties depend on the mass number. As mass number varies due to the number of neutrons, you see these isotopes. What is the reason for the chemical activity of an atom? The first is the unstable electronic configuration. The atom is unstable when its electronic configuration is not stable. It is very reactive. Therefore, it wants to attain a stable electronic configuration. While attaining that stable electronic configuration, it actually loses or gains or shares electrons. That forms a bonding between them, which is chemical bonding. We will learn about this chemical bonding in some other class. For now, let's learn about the octet and the duplet rule. Octet rule is that you should have 8 electrons in the outermost shell. By gaining, losing, or sharing, whatever you want to do, you do. You should have 8 electrons in the outermost shell. By that, the atom can become stable. Then is the duplet state. By the duplet state mein, you should have 2 electrons in the outermost shell. This is possible only in very small atoms which have the only one shell. If only one shell is present, then duplet state has to be there. So in this way, we have learned the chapter atomic structure. I hope you must have understood the chapter. Thank you.